This circuit diagram represents a solution to ECE-40084, experiment 1, number 5. Connect two LEDs and make one turn on the other. There are various ways to accomplish this, and I chose to use a photoresistor illuminated by LED 1 to the left in this picture, and that LED is in turn operated in response to a push button being pressed, and Arduino code which handles that sensing and the operation of the circuit from that point. There is an output LED which is also controlled by the Arduino, so that when the origin light source comes on, that LED comes on as an indicator. So that's the one that is controlled. The photoresistor is hooked up to an analog input, A0, which can read values from 0 to 1023. Now these correspond to a voltage from 0 to 5 volts, which varies as the resistance goes from a low value in bright light to a high value in darkness. For example, a typical reading in this setup is 901 when the scene is dark, which I should be able to accomplish by turning off this lamp. And we can see it on the serial output on the computer. The raw voltage is 911, or the raw level of that 0 to 1023 analog input is at this point 909, 910. So a typical reading in this setup is, for example, 901, and when the scene is dark, and the voltmeter would read, in that case, about 4.38 volts. So I'm pretty close to that. It's just as a result of different ambient lighting right now. And so not surprisingly, that value of 901 over 1024 times 5 volts equals 4.399, which is within a margin of error to that 4.38 that I told you I saw displayed in a prior run of this experiment. So the press of the button causes the pin 3, input pin 3, to be taken low, and that then turns on the yellow LED by way of output pin 4, and by way, of course, of the control logic. This causes the LED to shine on the photoresistor, causing the resistance to change. So if I do that with the if I press the push button, and you can see that that LED comes on, the voltage has dropped significantly because of the higher resistance, or excuse me, because of the lower resistance, because of light illuminating the photoresistor. And as that value is read at input A0, the logic turns on the output LED, as you can see in the top part of the breadboard. The circuit is a little hard to see. Now notice that that red output LED came back on. That's because the ambient lighting has increased to a much higher level again. This circuit is a little hard to see because I have a lot of components hooked up that I leave hooked up just to save time while switching from one circuit to another. But only the Arduino on the left and the breadboard on the bottom are active right now. So the output LED is visible here, and it's hooked to plus 5 volts and to ground through a 330 ohm resistor. It's not connected physically to either of the push buttons that you can see at the top. The lower one, though, is the one that is active in this circuit. You can see that the photoresistor is in direct proximity to the LED, which controls it. And that's a basic circuitry. When I shut off the lamp, press the push button, voila, one LED controls the other. And there is a slight delay time, which is to be expected for the photoresistor to change resistance in response to that illumination.